Hey everyone, today we're going to be looking at energy resources, which fundamentally asks the question, how do we make electricity? So we're going to be looking at different ways to create electricity, the different materials and resources used to generate electricity, and talk about some of the pros and cons of each one of these things. So the first thing that I need you to be familiar with is the idea of something called a turbine. Okay, so a turbine is functionally a really large fan that when it rotates, it has magnets attached to it, and those rotating magnets create electricity. So if I can make this thing spin, I can generate more and more electricity. The faster it spins, the larger the turbine, the more electricity that we manage to generate. And this is how we generate the vast majority of the electricity that we have, is by finding different ways, creative ways of spinning these really large turbines. Now, before I jump into the actual resources themselves, I need to establish two different terms that you're going to see a lot, and they are renewable and non-renewable. So the idea behind renewable energy is that this is energy that we are not going to run out of in the foreseeable future, or it regenerates itself. So this is energy that regenerates, or we have so much of it we are not going to run out. So this would be things like sunlight. Solar energy is considered a renewable energy resource. We are going to have solar energy for the entire foreseeable future, and if we run out of it, we are going to have bigger problems than just simply not being able to turn on our electric light bulbs, because that would mean that the sun is gone. So if it's a renewable energy or a renewable resource, that means that we are constantly making more of it, or there is so much of it that we are never going to run out. Now, a non-renewable resource, in contrast, means that we have a limited amount of this resource, and it's not regenerating. Or at least it's not regenerating fast enough. Regenerating. So coal or natural gas would be a good example of this. There is a limited amount of coal or natural gas that we have on planet Earth. And while, yes, technically we do get a little bit more of it, it takes a very long time for those resources to reform. And so we are using them up at a rate that we are eventually going to run out. So we can't wait for more coal or natural gas to be created, because that would take, hundreds of thousands, potentially millions of years for that to happen. And we kind of need it right now. So once we are out of non-renewables, we are out of them. You can't make more of them, or at least not in kind of a reasonable way. So those are kind of the big ideas. We've got renewable energy and we've got non-renewable energy. And predominantly, we are trying to find different creative ways of getting those to spin a large turbine so that we can generate electricity. Now, for the next section of your notes, I'd like you to go ahead and make 4 different columns. We're going to be looking at some different types of renewable energy resources. We're going to define whether they are renewable or non-renewable. And then we're going to go over some pros and cons for each one of these. So I've got 4 columns right here that I'd like you to go ahead and add. And the first type of energy that we're going to be looking at is called hydroelectric, which is fundamentally energy that we can get from flowing water. Okay, this is definitely a renewable resource, so I'm going to go ahead and put that as being yes. We're never going to run out of moving water. Now, some places will experience drought or something like that, but in general, if we ran out of water on planet Earth, again, we would have larger problems than not being able to turn the lights on. Now, there's a lot of good things about this one. The first one is that in general, these create very little to no pollution. All right, and they also don't cost much to run, so they're very inexpensive once they are started. Now, building a hydroelectric dam is expensive, but once you have that hydroelectric dam moving, it doesn't take a whole lot just to kind of keep everything going. So once you've got it up and operational, very inexpensive to work with. The cons is that you can only build this in certain places. So limited location is what I'm going to refer to that. You can only build it in places where there is strong water flowing. Not every river is going to work. For instance, the river that we have here in Yuma, especially when you get to like close to downtown, not strong enough for a hydroelectric dam. There's just simply not enough water flowing there. But if you go to places like the Hoover Dam, where they've created this basically large man-made waterfall, you have a lot of potential there for a lot of electric power. And what you're doing is you're converting that gravitational potential energy of the water once it's up high, and as it moves through the turbine, it's using that to spin that giant turbine. It's kind of using that gravitational potential energy to do that. So you've got some limited locations, but once it's up and running, very inexpensive, and you're basically using water to spin that large turbine, which then creates electricity. So that's hydroelectric power. Very easy. The other obvious one that we get with renewables is wind. So wind powers or wind turbines, you've all seen these if you've traveled pretty much anywhere towards California. They tend to do large wind farms near the mountains. This is definitely a renewable resource for certain. And again, we have basically no pollution involved. There's a little bit with the actual manufacturing of the windmills, but once they're up and running, very little pollution involved, a little bit of noise pollution, that's about it. And this one is actually, unlike hydroelectric, it's pretty easy to find a location for these. You can put them just about any place where the wind is consistently blowing. However, the issue with these is that they are very large. Wind turbines are massive. They are much larger than you would think they would be. They require a lot of maintenance. You have to keep them running. And unfortunately, they only work, I'm going to put it that way, they only work when the wind is blowing. If the wind is not windy enough on that day, they don't generate any electricity. So they're really effective. They're not very consistent. If you want to put these ideally in places where it's almost always windy, the bases of mountains is a good place to put them. Mountains generate a lot of wind just by the way they kind of direct the air. So that's a great place to put them. Other people will argue that there is a con, that they can be kind of ugly to look at. That's kind of, everybody gets to decide what that looks like, but those are the major pros and cons for wind, is that they're large, they require maintenance, and they really only work when it's windy. So if you ever have a day that it's not windy, you are not going to be generating any electricity off of your wind turbines. Okay. The other major one that we deal with for renewables is going to be what's called geothermal. Now, this is two words that you've probably been familiar with. Geo means the earth. Thermal means heat. So we're generating energy off of the heat of the Earth's crust. So this could be like boiling water in places where magma is close to the surface, which is the most common way to do that. There's a lot of that in the Imperial Valley. In places with a lot of volcanic activity, so a lot of Pacific islands and stuff like that. Hawaii has a number of these. They get as close to a volcano as possible. You pump water down inside of it. That water begins to boil because of how hot it is, and then you capture that water again with a turbine. As that steam begins to rise, it spins the turbine, generates electricity. So again, we're looking at very, very low pollution. This is not a no pollution, but definitely low pollution environment. And it's really, really cheap to run these. Basically, you're just pumping water down into a hole in the ground is functionally how it is. It's a little bit more complicated than that, but that's a really good kind of simple way of thinking about it. So again, low pollution, very, very cheap. However, again, kind of like with hydroelectric, we have extremely limited locations that we can use this on. Okay, you have to find a spot on Earth with exactly the right conditions for this. You can't just dig a hole that's deep enough everywhere to reach kind of that Earth's mantle where it's going to start getting hot enough to boil that water. So there's only a handful of places on Earth where this works really effectively. We just happen to be living next to one of them, which is in the Imperial Valley. Now, our last major type, and I apologize if I said that before, the last major type of renewable that we're going to be dealing with is solar. And this is the only one that does not require a turbine. Solar cells generate on their own, which means as a pro, once they're running, they're basically free to operate. They require very little maintenance. You clean the panels off every once in a while. And again, we've got basically no pollution from these. These are the ones you're probably the most familiar with because lots of people decide to put solar panels on their house. They are expensive to set up. As anybody who has solar panels on their house will tell you, the initial investment is pretty expensive. For one house to put solar panels on, it can be upwards of $15,000, $20,000. And again, if it only generates electricity when it's sunny. So that's going to be a problem in some places where it's not consistently sunny. We happen to live in one of the sunniest places on Earth. So it's not really a big issue for us, but for other people, it might be. Now, the last two that we're going to be looking at are the two examples of non-renewable energies that I want you to know. And the first one is, I'm just going to group them all together. These are going to be their fossil fuels. Okay, so this is energy that is being made off of dead organic matter that has been compressed under the pressure of the earth, and it turns into things like coal. It could be gas or petroleum, which we refine into gasoline or diesel fuel. This is also going to be natural gas. So any of those are considered fossil fuels. And these are big examples of non-renewable energy. Okay, they are, once we run out of them, they are done. Now, as far as the pros are concerned, these will always be available to us. There are no limits. So we got running, they can run 24/7. Unlike wind or solar, it doesn't matter if it's windy outside or if it's sunny outside, they always work. They're very inexpensive to run. They're very cheap. It's easy to generate a lot of electricity using very, very small, and they're relatively low technology, which means they're easy to maintain. Now, the cons, however, are these are all going to be a much higher pollution source. They generate large amounts of carbon dioxide, which is bad for the environment. They generate other pollutants, which can cause people to be kind of sick. And again, they rely on limited resources. They're non-renewables. So once we run out of fossil fuels, we have to find replacements, either by doing more extensive drilling and mining to try to find more of them, or by coming up with new technologies. And one of those new technologies is going to be the last one that I have you add to your notes, and that's going to be nuclear energy. So nuclear energy, again, I'm going to categorize it as a non-renewable. It's fairly clean, and we're not going to be running out of it anytime soon, but you do have to mine a lot of uranium, and eventually we are going to run out of uranium. However, as pros, it generates a large amount of electricity. There we go, generates lots of electricity. It's very, very efficient. And so it's very, very popular to use. A lot of countries are using electricity right now. The major con is that nuclear energy is difficult to find. So I'm going to say it's hard to find resources. Plutonium, uranium, these things are difficult to kind of acquire the nuclear fuel. And nuclear waste is basically immortal. So it's very difficult to dispose of. there we go. Difficult to dispose of. It's always going to be radioactive. We do things so extreme as like locking them in mountains and things like that. It's once you've got nuclear fuel or the kind of the nuclear waste after it's stopped being usable nuclear fuel, we just simply haven't come up with a great way of dealing with it yet. Now, you'll notice for one thing that I didn't put in the cons is that there's no kind of the danger or associated risk with this. Nuclear power plants are much safer than most people associate with them. We think about major disasters like 3 Mile Island or Chernobyl, Fukushima. Those are by far kind of the exception to the rule. Nuclear power plants are usually extremely safe. However, when they go off, they do definitely go off, and they can cause really significant problems when they do fail. So these are the major energy resources that we're going to be dealing with for kind of this upcoming project. And hopefully this chart will help you figure out some of the pros and the cons with them and figure out what you can be using.